Hello. So this is my implementation of a blockchain. So my blockchain supports three commands. The commands are sync. This this sync command is like the first command any new node broadcasts to the network when it joins. It just sends it to the nearest node it can find and it updates it with the latest state of the blockchain. Then broadcast is when a blockchain receives a transaction and wants to broadcast it to other nodes, or when a node has finished processing a transaction, that's mining it, and wants other nodes to know about it. So that's what a broadcast is. And a transaction is normally emitted by a client. When a client has a new transaction to broadcast to the blockchain, it does that and then wait for confirmation back. So I'm just going to give a visual demo now. mm, I've already written a script that will set up things like setting up the genesis block, those initial things that are needed to bootstrap off of. And this is what the script looks like. Basically, this miner.name serves two purposes. It mines coins, it mines new transactions, and also it sets up the genesis address when you run it as a standalone file. So I'll just set up everything without wasting much time. And as you can see, it has created a new database for the node. Inside this folder, the node manages its own state. Every other node in the network will just manage its own database, make sure everything is up to date with himself without depending on other people. That's what that decentralization means. And then for the clients have to manage the wallets of their users. That's like it should be this wallet database is like a wallet store. It contains many public and private keys that the user can use in transactions. So they have to use databases to keep their state. So let's just run a node and send a transaction to see what it feels like. So I'm inside the node here, and this place, let's move it to the client. So a client stays here, and from inside this client you will see that I've already set it up in a way that it will first create a new wallet with the private key and the secret key. Then this is the receiver's address. When we create the private key, it's normally is yes it can is an most times it's not a UTF-8 string, so it's not very visible, it looks ugly, and I'm afraid it might break something, so I normally encode it. And the encoding scheme I use is base 58. That's the same one Bitcoin used to encode this address. So I use base 58 to encode it, not base 64, base 58. And then here now I send a transaction to this new address I just created of one shitcoin. So we'll just send one shitcoin to that address. So let's see how it goes. So the node is listening, and the client has sent it. It's proceeding to mining the funds, and this is the whole body of the request. We first specify the protocol, the version of the protocol, the command, that's transaction. Assuming it was a broadcast, this will be broadcast, and this is the length of the data from here up to here. This is the length, and then the after processing, it sent back the details that after processing this, he mined this and completed it with the nonce. That means this is the nonce that when you hash this, I use SHA-256, the hashing scheme that is very popular to hash as my hashing method. So when it is done mining, this was the nonce that gave us a hash that starts with 4 zeros. So that was the random criteria I made everything to meet. I wanted every hash to start with 4 zeros. So if the hash is 4 zeros, it's a legit transaction. And this node now has gone on to broadcast these transactions to other nodes. And the main reason I can't really demo another node is because I'm on my computer network, and like the only way I can run another stuff here is through another port, and I want every of the ports to be this. It just messes everything up, but it works. I've tested it by changing the port. So this is how it works. Thank you.